This is lesson 33-2. It's on cylinders and cones. Here it tells us that a cylinder is a set of all points in a space that are a given distance, and that distance is called a radius, from a line known as the axis. And you keep reading, and they tell you that you have two bases, and if the two bases perfectly aligned above each other, then it's called a right cylinder. So we're gonna label these. Okay, so this thing right here is a radius. Looks like we have another one right here. Okay, here's the axis. Because this is a right cylinder, this edge right here, with the distance from this base to this base, that is the height. If it's not a right cylinder, then we'll have to look here for the height. But in this case, these two distances are exactly the same. It says describe the shape and size of a cross section that are parallel to the bases. So if I take a plane and I slice right through this thing right here, and then I look at the cross section, I'm going to get a circle. And if I go down here a little bit closer to the base and I slice through that, I'm going to get another circle. So as long as it's a right cylinder, we'll get circles that are congruent, that are the same size. Boy, my wavy line didn't stay wavy, did it? Okay. Oblique cylinder. Okay, that's not too hard. Here's one base. Here's another base. So the distance between the two bases is going to be, a perpendicular distance. You'd have to measure that distance right there. This is not the height. So the edge of the cylinder is not the height when it's oblique. This is the height. Okay. So we've got Lynn working on this. Looks like a net. I'm concerned about this net though, because we've got a small circle and a big circle. And it says, which one of these bases is the right size for the cylinder? So if this is what we have to wrap around, we have to make this side length right here either fit around this circle or fit around this circle. Well, that makes me think around a circle, makes me think about the circumference. Okay, and the circumference, one of the formulas for circumference is 2 pi r, but you know what happens if we multiply 2 times the radius? We get the diameter. And the diameter of the circle, I hope it's going to let me do what I want to do. We draw that diameter right there. It's not, well, it's okay, I don't care. If we draw that diameter right there, we think about pi being 3.14. That means that to get all the way around this circle, I need to multiply my diameter times itself, or I need to multiply my diameter, the length of my diameter, times a little bit more than 3. So if I take this diameter right here and I move it out, okay, and then I measure the diameter again. Okay, let's see. Oh yeah, it's gonna let me do it this time. And I move it out. Okay, now that's about 3 diameters right there. And those 3 diameters do not get me the whole length. So I'm thinking this one's a little bit small. So I'm going to go down here to this one and get a rough idea of how big that diameter is. Okay, and I'm going to move it out. And then I'm going to give myself a diameter. And again, that's just a rough estimate. But there's another diameter right there. And you can see that I'm almost at the end. So that 0.14 is going to get me the rest of the way. And if you're not real sure, I can move it closer to here. There we go. See, I'm really, really close. So that means that this one, the bigger circle, is the base of the cylinder. And that means it will fit along this when we fold. So we fold this paper around the cylinder, it will fit. This I would have overlap. Explain how the dimensions of a rectangle and net relate to the cylinder once it's constructed. So this right here, this is the height, because that's how far apart the 2 bases are. I'm going to have one base on this side, I'm going to have another base on this side. The distance between the bases is the height. And then this other dimension right here, this is going to be the circumference. Of the cylinder. Okay. All right. So now for a cone. A cone is much like a pyramid in that it only has one base, and it's got this vertex up here at the top. It's a right cone if the vertex is right above the center of the circle. If the vertex is not above the center of the circle, like these over here, then these are oblique. This one's oblique, this one's oblique, this one's oblique. And they're showing you right here, you always are going to measure the height, is how far away is the vertex from the base of the circle. Here's the vertex. How far is it away from the base of the circle? Remember, the distance is always measured in a perpendicular distance, okay? So all of these right here are the heights of this oblique cylinder. Oblique cone. Says compare and contrast the shape and size of a cross-section of a right cone. So this cone right here that is parallel to base with the cross-section of a cylinder. Well, the cross-section, I've kind of got them drawn right here. The cross-section here, we did this on another problem. You do several cross-sections and you get congruent circles. You do several cross-sections right here and you're still going to get several circles. The only difference is they're not all going to be congruent. So for this one, you get congruent circles. For this one, you get circles, but not congruent. Not congruent circles. Okay. Describe the cross-section of a right cone that is perpendicular to the base and contains the vertex. I believe it's going to be a triangle. It's pretty easy to see that triangle right there. So if I take that and I slice it right here, I get a triangle. It contains the vertex. You get a triangle, and not only a triangle, but you get an isosceles triangle. Okay. We've got a problem to work over here. Lynn knows the height of a cone. And they said that we can work with 2 similar triangles. So I've got the first one named triangle VPQ, and then the next one is going to be triangle VCA. And they want us to explain why we know these are similar. Well, we know by angle similarity. Where are the two angles? I have a right angle right here, and I have a right angle right here, and they share that angle right there. So we've got one pair right here, a second pair up here. That means that I can write a ratio of parts. So they told me that the whole height was 30, and they told me that the distance between the cross sections was 20. So that means that if the height is 30 and this bottom piece is 20, then the top piece must be 10. So of triangles right now, and I have to use the similar triangles. I can't use the pieces of parallel lines because I'm using I'm not using the transversals, I'm using the parallel lines. So this is R right here, this is 10, this is 30, and this is 9. So I said 10 compared to 30, so the short side right here compared to this, or the leg of one of the small right triangle compared to the leg of the big right triangle is equal to the radius of the small triangle compared to the radius of the big. Notice I put both of the small pieces of information on top, the big pieces on bottom. I could have flipped them upside down, but you just have to be consistent. So I'm going to cross multiply, and I'm going to get 90 equals 30R, and then I'm going to solve that, and R is going to be equal to 3. Divide both sides by 30. So that means that the radius right here is 3. Now that I know the radius, they want me to find the circumference and the area of this smaller cross section. So you just have to know the formulas. And the formula right here is 2 times 3 times pi. So if I leave it in exact answers, it's 6 pi. And then this one is going to be, what, 9 pi? 3 squared. Okay. And that gets us to the end. So the next video that I do will be going over the answers. So give this section a try.